Good morning, everyone. This is Amarnath here. I'm going to explain you today an important topic called Apache Kafka and Spark streaming. Apache Kafka will be integrated with Spark, and I will show you how Kafka feeds comes into Spark in real time called Spark streaming. I'm going to explain this implementation to you in terms of a DevOps environment, how things will work in DevOps using various development tools is my agenda. So implementation of this process, I'm breaking it into three parts. First one is I'll implement this one in DevOps environment. Second one will be I will implement this one in Cloudera distribution of Hadoop, and third one will be I will implement this in the Hortonworks distribution platform on our cloud servers. So the reason why I'm implementing it in three different distributions on three different fields is a viewer or a learner will get a clear picture of how the configurations are different from each distribution. Though the core functionality and the logic is same, the way how it is integrated and how tools are made to work on each distribution is completely different. For example, if you take the case of Cloudera, first I have to download the parcels, I have to distribute them, I have to activate them. Once the Kafka parcels are activated, and then I have to take them onto uh, different distribution port numbers has to be given, consumer port number has to be given, and producer port number has to be given. These are the configuration things I'm discussing here. So when you come to know how it works on each individual platform, things makes more easy for you. That's what my agenda is. So today we are going to discuss it in terms of DevOps environment. So first of all, I'll explain you what is DevOps. I'll explain you what is Homebrew, and what is a Vagrant tool. Today, the DevOps tools which we are going to discuss are two things. One is Homebrew and Vagrant. Vagrant, I'll just show you what it is, but I'll implement this Kafka implementation through Brew. Okay. For the people who are not aware of DevOps environment, I'll just give you a 1 minute of quick glance what it is. So DevOps is nothing but DevOps is a culture, or we can see it is a practice that emphasizes the company in collaboration in communication of both software development and information technology. So it can be requirement gathering to design through testing, debugging, deployment, and then maintenance. The complete life cycle has to go through a separate different models called waterfall model, software engineering model, prototyping, incremental, and agile, scrum methodology. So different companies follow different process. So I'm just giving you a introduction about that one now. So on top of it, if you ask me, as I'm working in DevOps environment, if you ask me what is it all about, it is just simply automating the process of software development and infrastructure changes. When I talk about software development, it starts from planning phase to delivery phase. That is what DevOps is. So you should be very quick enough. You should be very efficiently doing the best practices of completing your delivery, including development in the easiest, fastest, and efficient way. How that can be done are there are several tools that help us in doing this one. So I will go through that tools now, which is Brew and Vagrant. Okay, so first thing, let's talk about Homebrew, and then I'll show you how the Vagrant also works. Bear with my throat, I'm having a bad throat, so sorry for that. First thing, what is a Homebrew? If I do Homebrew here, see, sorry. Homebrew is nothing but it is a free open source software package management system, and I exclusively available only for Mac operating systems, for Apple Mac OS operating systems. So Homebrew has been recommended because it is very easy to use as well as integration into the command line prompts. The other way, what I can say is Homebrew has made things very easy for you to deploy and complete your deliveries in a most easy way. You will be amazed to see how I will complete the Kafka configuration, Kafka setup, Apache Spark installation, and Spark streaming so easily in max 15 to 20 minutes. Okay, this is what about DevOps. This is what about Brew. This is what about Wagner is. So let's go into our ideal scenario of Kafka. Okay, guys, agenda is very clear. We are bounded to complete the practical implementation of Apache Kafka. So I don't want to waste so much of time in theory. I would urge every one of you to please spend 2 to 3 minutes of time to understand in the background how things will work. Okay. So first of all, I'll explain you what is Kafka. Apache Kafka is one of the open source message broker project. This is also developed by Apache Software Foundation. This is written in a Scala language. The project aim is very simple. It is unified. It is highly throughput. It has low latency platform for handling real-time feeds. It makes sense to all of you if I give you a real-time example. Okay. For example, uh, when you submit all your details in one of the telecom company, for example, I'm going to buy a new sim card, and I'm asked to submit all my details correctly, including my home address, my personal identification number, or my passport questions, including my credit card number. Okay, when I complete my customer journey correctly, that is called as one event. Okay, the way how Kafka will be used with this events is, uh, in an event I create a topic. For example, customers who are calling to India so frequently is one topic I create. Customers who spend so much of money on data consumption is one topic I create. So when collecting the when I collaborate all the user details here collectively, I can segregate them very easily, which would help me in understanding, coming to an estimation, how much how much I'm gonna earn, or how I can predict my business model to increase my sales. Okay, so event is nothing but events depends differs from environment. So as I'm giving you a telecom domain example now, the customer journey is considered as one event. When customer submitted his details perfectly, those events in a web form will reach your Kafka, and if you create a topic based on that topic, that things will be filtered and goes into your level 2. Level 2, guys, processing engine, which can be Storm, which can be Spark, which can be different. And the way the filters are implemented is also different. Somebody uses NiFi, somebody uses Flume, somebody uses Storm topology as a whole, as an ecosystem, all these things. I'm not going very deep to explain what is Flume, what is Kafka, what is the difference between them, but you need to understand there is another concept called Flume which works in the similarly like this, but underlying process has uh, sink, channel, and source. Source will be anything where you want data to be coming into, and channel is, you'll explain how you wanted to send the data into. Sink is the one who is taking the data. Okay, here in Kafka it is very simple. It is, this design is heavily influenced by the transaction logs. So first time Apache Kafka was developed by LinkedIn, and the conceptual design is, you'll have a producer, you'll have a consumer, you'll have a Kafka cluster. Your Kafka cluster will be very closely working with your Zookeeper service. Your Zookeeper service keeps interacting with Kafka cluster to ensure that the Kafka cluster is up and running. So let's go into the role of the consumer and producer. Producer produces the logs or information or feeds, and it's a responsibility of consumer to go ahead and consume them and show them in the real time. Okay, Uh, to explain it more clearly, I will create some rubbish data. Let's assume that rubbish data as the customer data coming in, and we will see how the data will be pushed into the consumer as a real-time feed. Okay, I'm going to implement this one using Brew, as we are talking about our DevOps environment. And before I jump into it, I'll recap once again. uh, this is a simple Spark streaming context set up with Kafka on a Mac operating system. We are using Kafka Broker, and we are creating a topic with which the Spark streaming context listens to. Uh, Spark streaming context is also called as SSC, where we will create a console and ask it to invoke the command. And it keeps posting the messages, which will make things more easy for you once I start implementing it. Okay, so I don't have anything now. If you see here, I don't have anything installed. I'm starting it from the scratch. So let's go ahead and start our practical work now. Hope I'm clear what DevOps is, what Brew is, what Vagrant is, what Apache Kafka is. Don't worry about Spark. Spark we don't need it now. Let's complete Kafka first, and then we'll talk about Spark later stages. Okay. So I'm using Brew now. Let's start now. So as I have told you, we need Zookeeper. I wanted to install Zookeeper. Brew install Zookeeper. It's doing it. Perfect. It's downloading it. It's done. Very good. So I wanted to search if I have already installed Kafka. It seems to be there. Okay, I have Kafka related libraries, but I don't have Kafka service. So let me install it. Perfect. Kafka is installed now. So what I wanted to do now here is, let me see if the Zookeeper service is started. If no, I'll start my Zookeeper service. Brew services start Zookeeper. Perfect. Zookeeper service also started. Guys, one important thing I wanted to make everyone to be well aware is, on my Mac, the way Brew works may be little different. I'm not telling completely different, will be little different because I have experienced it and my colleagues also experienced it. Because in every time when you install Homebrew, uh, it will go ahead and install all your services in a specified location. In my machine, Homebrew is already installed, so I have not shown you that. But if you try installing Homebrew, it should go through a location called cd user local seller. Sometimes if it's not in that location, you'll have to find where the Brew is installing all the components. Because today's agenda, we are installing Kafka, we are installing Spark, we are installing Zookeeper and everything. All those things will go into Brew's home directory, which is, do you see this? Zookeeper. Today is October 5th and time is 12:04 p.m. just a minute back. And if you see Kafka, 12:05 October 5th, just 1 minute back, and that's what it is. So please be aware your services will be installed in this location. And if it is not in this location, please be aware during the installation phase to make a note where it is installing. Simple. Okay. So as I know my Kafka is installed now, I'll go ahead and start my Kafka service. uh, Let me go into Kafka. I know there is a with which service is that, 0 point something. Yeah, perfect. And in this I should have a lib. Perfect. And in this I should have a bin. Perfect. And here I'll have a Kafka start, Kafka server start.sh, because I need to start the server. Start.sh. Perfect. And also I'll ask it to go ahead and invoke the properties local etc Kafka. Perfect. So guys, let me explain you what I'm doing here. everybody know how the things works in Linux environment. So you'll have your shell scripts or the configuration that starts your service. You need to go there and invoke that command. And here the reason, once it is invoked, I'm asking it to go and refer to the Kafka server properties directly. Okay, that's what I'm just giving a command to proceed in that way. So let's see what it does now. Sorry, it's not a directory, so I shouldn't be using it. See, perfect. Kafka started. It's very good, and it is also telling what are the various partitions it has. Okay, fair enough. Guys, let me tell you something here. As you have started your Kafka service, let's keep this window open and open a new window for our work. Okay, I'll open a new window here. Fair enough. So as I have started my Kafka here now, I also have to make sure whether my Zookeeper and how my Zookeeper is communicating with Kafka through a broker service. Let me do that now. I know it is in user local cellular. I don't want to copy and paste because it will create an unnecessary issues during copy paste in Brew especially. So kindly please be patient, and when you practice also don't copy and paste, because the way it changes the space delimiters and exclamatory marks will create an confusion to Brew. Kafka 0.10, and in it we have a lib, we have as bin or bin, yeah, bin. Kafka console. Before that I wanted to explain something here. Hold on, I'll show you the Kafka consumer and Kafka producer shell scripts. ls-l. Okay, if you see here, guys, you have a Kafka consumer and you have Kafka producer. Okay, Kafka consumer consumes the data from producer as a feeds in terms of real time, and Kafka producer is the place where the data comes and falls. It can be web, it can be web logs, it can be customer journey data, it can be your generated logs, you might be analyzing some logs or something like that. So that's what it is. This is the location where you have all your shell scripts, and you just need to invoke them when you wanted to start the service, stop the service, or have your consumer and producers running. Okay, have my consumer groups here, and I should also have my producer groups here. Okay, it's a replay log, so everything is here. That's what I was trying to explain here. Okay, so here what I'm doing is I will go to my home directory, and I'll give full location here because I don't want to get confused. This is a local Kafka 0.1.0, and in that I have libexec, and in that I have bin, I have Kafka console consumer. So I'll just see and tab. Perfect, I agree with you, and I'll explain this one. Don't worry, what I'm doing here I'll explain you right now. Zookeeper, I appreciate that. And local host and port number. Sorry, I think there is some. I minimize the window because it is going beyond the. Okay, localhost, and then I'll give command 2181 because this is the port number through which my Zookeeper listens to the Kafka consumer. Fair enough. And I'll create a topic now called Kafka demo Spark, and I want my producer to take data from beginning. BEGINI. Okay, there's no complex things here. You're just going to the location where you have your shell scripts and you're invoking them, and you are also initiating it with a Zookeeper service, and you gave your Zookeeper host name with a port number, and you created a topic called, you are asking it to create a topic called Kafka Demo Spark, and you want your producer to fetch the data or your consumer to hold the data from beginning. Okay, let me see what happens. From beginning is not recognized option. I agree. I might have given a spelling mistake there. Begennning. It is taken it. This is already there. This one is explaining the work we have done earlier. So I don't want you to guys to confuse that. I will cancel this and I'll create a new topic now. And my Kafka is now. Thank you, Kafka. So our part of consumer to this is an earlier exercise what I have done to ensure that my services are working, and I wanted to follow the same process while recording the video. So don't worry, there is already a topic called Kafka Demo Spark, and these things were part of that one. Don't worry about that. And we are going to start a new topic now. Our new topic is Kafka real time stream from beginning. Okay, so it is open now. Your consumer is just waiting for your producer to produce the data. As I have told you earlier, don't close this window, also keep it open, and we will open a new window and initiate our producer. Okay, so same thing with producer also, but you need to invoke producer console.sh instead of consumer. Okay, user local seller, and in that I have Kafka. I have version of 0.1 0.10. In that I have bin, and I should be having Kafka console producer. Perfect, producer, and I have .sh here. Perfect, I agree with it. So earlier you have given your Zookeeper, and here you need to give your broker list. Broker list is nothing but the communication platform between your Kafka consumer and Kafka producer. Okay, broker list. Please be aware of the port numbers. Port numbers for your consumer is 2181 with Zookeeper, and there is a change in the port number here. I want you to be well aware of that, please. It's 9092. Fair enough. And I'm giving a topic. What is our topic name? Topic name is Kafka real time stream. Okay. Let me go through the command once again. Did I give it correctly? User local seller. The Kafka console produce.sh is perfect, and then I'm initiating the broker list with 2 lines and 1 line. Okay, I agree with that. And localhost 9092 is right. Topic is Kafka real-time stream. So here, what is a Kafka real-time stream and Kafka real-time stream? I'm just ensuring that I'm not doing any spelling mistakes, because that will create other confusion. Okay, so now let's go and see what happens. Same thing. The way I have invoked the shell script of consumer, I have done the same way for producer, asking it to be in touch with the broker list with the respected port number what it wanted, and then it took it up. Okay, it's not a file or a directory. Did we say? One second, guys. Let me check what was the mistake there. I have things ready also. The point is, I have went through this error message a lot of times. I have my command, I have my knowledge base article ready with me. I can use it, but when you copy and paste it, it will create an unnecessary confusion. That is the only problem. I have faced it with Brew. So this is where I am now. One second. So we are giving the topic here. This is what I was discussing now. Okay, let's do that once again. There seems to be some problem there. Where am I? Let me check. Where am I? Okay, this is fine. No, I did not have to use user local Cellar, and then Kafka, and then 0.10 bin Kafka console. This is where it is not trying to Kafka console producer .sh broker list. If I'm not wrong, yes, that's broker list, correct. And in that I have to give a space and local host with the 9092 as a port number, and my topic name is Kafka real time stream, stream. Mhm. I missed something here, which is nothing but libexec. That is a problem. Now I realized it. You should be going to libexec. You have been okay. That's a mistake we have did. Okay, guys, we have initiated the shell script. I mean .sh, and you give the port number and Kafka real time stream. Okay, now see the magic here. You go to right, and you be on left, or you stay here. You stay here. Where is my producer? This is the producer, right? Hi Kafka. See, I just entered Hi Kafka there, and you said you have seen Hi Kafka here. This is my producer, and this is my consumer. Okay. Thanks Kafka for taking the feeds so quick, real time. See, I have just entered thanks Kafka for taking the feeds to real time. Now this area will be the one where your website information or your customer journey or your JSON files of a customer comes and falls over here, and the way you process them is the storm topology some companies follow, and Apache Spark processing some companies follow. With this, we have ensured we understood the Kafka process, we have set up the Kafka process, we have seen how Kafka is acting as a message broker and sending the message feeds from the producer to consumer. Okay, I'm not stopping it here, but half of our work is done. Let's focus on the next part of it. So now, as this is completed, I need to install Apache Spark. Guys, Kafka setup was so easy. There's no big complexity in that. But Apache Spark, the reason why I tell you is installation of Spark is one important thing, and you define your Spark build tool console is one important thing. You have to do it very carefully. Once your Spark build tool and its console is perfectly made with correct configurations, it will work without any issues. Okay, so 1 minute on Apache Spark. If any new starters are listening to this class, Apache Spark is one of the open source clustering computer framework which works on a resilient distribution of data structures or data sets. So I can say this provides programmers with an application programming interface which works on the data structure, and that data structure is called as really resilient distribution data sets called RDD. And I started loving Apache Spark because uh, it it simplifies your work, and developers who tend to write 100 lines of Java code can simply uh, uh, perform the transformations or aggregations or do any kind of data manipulations in Apache Spark in 2 to 3 lines as max. That's what is Apache Spark is, and there is significant changes and improvements coming up in Apache Spark in every release. So I was started using Spark in from 1.2.1, and now it is in 2.2.0, 2.0.0, which is the latest release. So that's what it is. So I don't want to waste any time further on Spark. just explained you what Spark is. Okay, and now let's go and install Apache Spark the way we did for Kafka. Brew install. Spark. Already downloaded. Fair enough. Thank you. And now let me go to that location where my Apache Spark is sitting and how is it behaving there. User local seller. Fair enough. If you see this one, I should have Apache Spark here. Yes, it is there. And in this, should have something called version of Spark, which is 2. Yes, I have it. And then I should have libx like the other one. Fair enough. And in bit, good enough. And here, if I go and show what is inside, see guys, your Spark submit is the one that works. Your run example, your Spark are your Spark environment variable, and your run example also. Okay, this is the same thing what we have seen earlier. So now I will start my start master.sh. There's no directory here. Okay, let me go to one directory back and see where it is. pwd libx. I'll check my knowledge base articles. Nothing wrong in that. It's has been not been. Sorry. cd has been ls minus altr. Spelling mistake. See, you have all your services here. So what I'll do is I will start my service with the command start master.sh. Master.sh. Perfect. That's good. That's very perfect. So it is telling starting org.apache.spark deployment master, and I wanted to confirm if my web interface is taking this up correctly. Let me also check that. Localhost 8800, sorry, 8000 or something. One second guys, I'll just check the port number. Should be 8080. I'm sorry for that. Let me check once again if it is 8080. Yeah, perfect. It's working now. My Spark has taken the necessary things and it is showing me the Spark master at Spark. So till here we have done things correctly. My Spark interface is taking its necessary information. Is my screen shared? Screen shared. Okay, cool. Fair enough. So till this point it's fine. We have one second. Clear. Okay, I've just cleared it out now. So I have shown you the Spark is working pretty well, and what I have to do is now I need to build my Spark build tool, which is very important, which has some console properties which need to be checked very properly. For that one, what I'll do is I'll go to home directory and create a test folder, and from there I'll have to invoke everything. Okay, I'm creating a directory called Spark demo test. Let me go into that. Spark demo test ls minus altr. I know I will not have anything here. Perfect, which is okay. So once I'm here, I will do a nano build.spt. spt is nothing but your Spark build tool, which will take all your configurations for your job to run with the configuration with the given instructions. Okay, so guys, one important advice and recommendation here: do not use sudo in any phase of this complete uh, project what we are doing now. Because what happens is, if you do any activity with sudo and Spark, when it starts running, it expects you to invoke that command as sudo also, which creates an unnecessary confusion, and we have to change so many files and properties and permissions. So please do not copy and paste, and do not, I'll show you the what happens if I copy and paste now. um, do not copy and paste, and do not use sudo in any of the phase. Okay, thank you. I have it here. Let me show you my configuration, what I'm going to put in my, this is the one. I need to mention Spark version, Scala version, and I have to say how it should, I have copied and pasted it. So the problem is, I have to make sure there is no space and unnecessary confusions to the Spark build tool console. This is fine, this is fine. And is any space on top of it? No. Okay. As it is nano, once you have ensured you are done with your work, click on Control X. It will ask, boss, do you want to make changes? Shift Y, yes, I want to make the changes. Done. So this is the important part. I'm scared here because as I've copied and pasted, I'm not sure if it will work. If it doesn't work also, I don't have any issues. I can go and write entire thing again. SBT console. It's working. It's working. I got it. It's working. It will go and, yeah, it is setting the project for your Spark demo test. It is resolving and it is getting all the necessary information from the repo, from the configurations. And yes, now your Kafka is open in the Scala context. Sorry, your Apache Spark is open in the Scala context. So you can use Python also if you want, but as I have told you, my Spark streaming takes the data from Kafka. I wanted to make sure it is doing things correctly. From here, guys, I'll show you set of configurations which we need to import. um, they are all packages which is pre-built, and if anybody has some idea about how the Java packages or how your classes work, you can go and spend some time on it. Explaining explaining the code is not an agenda. However, I'm also spending fair good amount of time in understanding each and every package and classes, how they work and all this stuff, which we will be covering in detail in the future classes. But now let's not focus on that one. Our bounded agenda today here is to finish the Kafka and Spark streaming. I'm just explaining the process, how that works. Okay, so I mean, I'm importing certain configurations for my Kafka as an input for my work to complete. The first one, I'm importing this one. There's nothing but you're asking Spark that we are using the Spark configuration in Scala context, which is fair enough. Taken it, very happy, no problem. And I'm creating a variable with conf, and I'm setting a values to it, and master as my local, and my application name is Kafka receiver, because that's where, that's from the where your Kafka has to get the feeds from. So this is simple as it is. Fair enough. And then if you see here, Spark streaming context, as you know, you are going to get the streaming or streaming feeds. You have to give that package to, you have to import that package and explain and give all the things necessary for Kafka to do the work. Okay, this is also importing it. Fair enough. And then streaming seconds, how many seconds do you want to stream? That also I'm giving here. Sorry guys, it didn't copy properly. I hate copy paste. Perfect. And then I'm creating a variable, and I'm asking Spark streaming context to take the seconds in the configuration of 10. Okay, ss is nothing but Spark streaming context, guys. I'm creating a variable and I'm creating a new configuration of it, asking it to take the seconds as 10 seconds. Okay, fair enough. Thank you, that's good, that's good. And now you are importing Kafka utils. Here, if you want to do a word count job also, you can do it. But you need to import a different package, or in the same package, you need to embed the code of counting the numbers of whatever the data that is coming into your feed. But mine is just streaming. It gets the stream whatever Kafka consumer gets and puts it over here. And each line is considered as one value for my program or for my package, I can say. Okay. Kafka utils also done. Fair enough. And now let me do this thing. I need to be a little careful here because I'm copying and pasting. I'll show what happens. If you see here, the exclamatory mark is in the wrong way. Okay. I wanted to make sure what's my topic name. Otherwise, there is a possible issues of things going wrong. Not this one. Kafka. What is the topic name? Kafka real-time stream. Fair enough. It's Kafka real-time stream. I wanted to see the spelling also. Kafka real-time stream from beginning. Okay. Kafka real-time streaming. Streaming or stream? Stream. See, if I have given streaming, it would have confused and that create an unnecessary ruckus. Kafka real-time stream. Fair enough. Which is 5. Okay. Perfect. It has taken things correctly. I'm happy for that one. And now I'll ask it to print my Kafka stream. Good. And if I see my Spark streaming context dot start, it should. Cool. Perfect. So it started it. If you see here, finished the job streaming job, which means it started streaming everything. Now let's go and make some change in our producer, which should come and fall here. This is all my producer. Hopefully this should be the producer. Okay. Is it the producer? This is consumer. Okay. Okay, Kafka. Oh, sorry, guys. This should be here. This should be in this here, which is consumer and producer. Okay, Kafka. See, when I have given there, that should come over here because bear with me. If you see here, this is my consumer. Unintentionally, a mistake I have given here, but it should go from producer to consumer. Producer is the one who produces. Consumer is the one consumes. And now, dear Spark, take this feeds for each line as an input. Okay, perfect. I have given it here and I got it here. These things should come up into my Spark. Okay, where is my Spark? See, and now dear Spark, take this feeds for each line as input. I got it. And before this one, I have given something else that should also come up. Where is that? See, you have null. Okay, Kafka. Okay, I'll show you something here based on the configurations of what my what my change has done, I'll give three enters here. One, two, three. Here also it went three. Okay. So for each enter is one line from my program. So I should see the same thing in my Spark. Okay. If you see here, see I got three nulls. In the same way, I can also do a word count job, but I have not made those changes in my package, but which can be done. So our agenda today is completed. We have successfully done the real-time streaming of data through Apache Kafka as a messaging service. And sorry guys, sorry for that. And that's how things works in the real time. So explaining it in more detail, I have already explained with an ideal example what is called one event, how filters are worked, how Apache NiFi can be used, and how those data can be used. Before completing this one, I will also do an easy way of coming out or cleaning everything what we have done till now. Okay, so hope you have understood everything what we have been discussing till this point. So you have done a great job of configuring Kafka and doing a real-time streaming with Spark. Let's clean everything and let's give Brew the way it is just 40 minutes back. Okay, I'll close one by one and I'll unlink everything. I wanted you also to know how you can do that. First thing to do it, to stop your SBT, which is Spark Bit Console job, you can just say Control Z. It stopped. Okay, I don't need anything here. Exit. Very good. I'm closing this to avoid further confusions, or I will use it to stop other jobs. Okay, so I don't want to cancel, I don't want to close it. I'll stop the Kafka service now because I'll go to the location user local cellar Kafka 0.1 is a version. In that I have libexec, in that I have sbin or bin, and here I will be having stop Kafka server. Yes, it's Kafka server dot, it's not dot actually, it should be this one, stop dot. I'm not sure if it works. Perfect. So I think it has stopped the Kafka service because it has taken it correctly. Okay, and I also need to stop my Brew Zookeeper service. Brew service Zookeeper stop, or it's Brew services, not service. Sorry for that. Brew services stop Zookeeper. Fair enough. It stopped successfully, and now I also need to stop my Apache Spark, which is user local cellar Apache Spark. In that I have version 2, in that I have libexec, in that I have bin. Here I have stop master dot sh. No such file or directory. I know this will kick me off like this. Let me correct it once again. Is it bin or has been? It says bin. I made the same mistake last time also. Sorry for that. Why am I going to Kafka, by the way? I should go to Apache Spark to stop Apache, right? Apache Spark. In this I have version 2. And in that I have libexec. In that I have sbin. Here I have stop master. Yes, stop master dot sh. It stopped. Perfect. And now you have stopped all the services. Great job. So don't confuse other services because they were continuously running. Let's go and close them as we don't need them. Otherwise, we will create a verbose logging and it will just simply fill up your disk space. Okay, so simple. It's Brew, Unlink, Apache Spark. See, it has 9 symlinks removed, which means it has done the job perfectly. And what are the entity relationships it has established with Kafka, Zookeeper, and everything, that links were removed. Fair enough. Brew, Unlink, Kafka. Fair enough. 27 symlinks removed. I understand. And next one is Brew, Unlink, Zookeeper, because Zookeeper is also one of the dependent, right? 13 symlinks removed. I appreciate that. And then what happened? We have uninstalled Spark, we have installed Kafka Zookeeper. Now let's go to our designated location and delete our directories. Cellar ls minus l, because you have stopped them. You have removed the symlinks, but you also have to remove the folders. Okay, Apache Spark rm minus rf Kafka rm minus rf Zookeeper. Simple. We have finished our important activity for today's agenda. We have understood what is DevOps. We have understood what is Brew. We have understood what is Vagrant. We have understood how Apache Kafka works as a messaging broker service, and how that can be integrated with Spark, and how you can get the Spark real-time streaming from Kafka. That's the agenda here. Before I end this class, I wanted to sincerely thank IT University and Durga Gadej sir for all his valuable playlist, and that's where I have learned so much of my. I've acquired so much of knowledge from his websites, and I would anybody anything regarding big data, Hadoop, cloud, you can go and watch IT University. It has got all the required information from starter to an expert, including certifications as well. Thank you, Durga sir, once again. Okay, coming back, we have completed our agenda. Before we wrap up, let me show you an important aspect. This one, guys. This is the Hortonworks preferred solution activation process. Here you have real time. For example, you have Apache Kafka, where your feed comes in. Once your feed comes in, your Storm will be acting as the processing engine here. As it is Hortonworks, they are using Storm because they have Storm topology proprietary and contracts with the open source. If you ask Cloudera, they would say completely no for Storm. They would say let's use Apache Spark. And that's the reason I told it's always very important in open source. You need to understand and work with different distribution platforms to get a clear picture how each and everyone working differently. Okay, and once that is done, once you have processed the data based on your transformations or aggregations or whatever it is, and then after that you'll ingest the data into your Hive using Scoop. Once the data has come over here, you can do whatever you want. But from once the data is processed already, you can use Solar as one of your service for your reporting or for your search engine or something like that. That's how it looks like. So I can confidently say uh, you have learned a very important DevOps utility tools like Brew, and we will discuss more things on how this can be integrated with Cloudera distribution and Hadoop Sandbox in later classes. Thank you all for watching this video, and I will share the knowledge base article what I have here, step-by-step instructions in the GitHub once I have the ready. And I sincerely appreciate every one of you. Thank you for watching this video. Have a great day. Cheers.